Good morning, ladies and gentlemen, and welcome at the Gulf Structural Design GSD IDEA webinar. Today we're focusing on the design of anchors. Very exciting topic. This webinar is planned for 60 minutes, so the 60 minutes will shorten your waiting time until the evening iftar, because we have a month of Ramadan, but this should not be the only benefit. The benefit should be also that you have fun and you learn something new, what brings value to your project. So we have quite a crew today. Together with me, I have our lovely product engineer, Rose. Rose, how are you today?
I'm good, Jan. Thank you. How are you? And hello, everyone.
I'm great. Thank you, Rose. We have also another product engineer in our GSD team, Venkatesh. Venkatesh, how's it going?
Yes, hello Jan, it's going good, and how are you? And hello everyone.
Perfect. And we also have a guest from IDEA Statica HQ from Europe who's sitting with us in the office. It's Dominik Boric, also product engineer. How are you, Dominik?
Hello, everybody. Hello, the team at GSD. I'm very excited to be here in Dubai. I'm doing great.
Awesome. And myself, Jan Barta, Director of GSD IDEA. I'll be your today's host. So let's get right into the next slides. We're using the GoToWebinar application. All of you, you're muted by default, but in case you have any question or any inquiry, you can ask via question panel in GoToWebinar. And yeah, what today is about in a little bit more detail. Yeah, it's the anchoring. So Rose will go through a little bit deeper of the issue. So she will explain what the issue is about. Then Dominik will explain more about the various workflows and the main principles. And Venkatesh at the end will guide us through the whole demonstration in IDEA Statica, how the anchor design can be done seamlessly. And at the very end, we have Dominik sharing with us the tips and tricks from the modeling that he collected around the world. And if you bear with us until the end, there's a little surprise for all of you. Before we get to that, there's just a little recap of what IDEA Statica does. So the project nowadays, they're definitely not getting any easier. The complexity grows, the deadlines are not shorter. If you live in a different world, let us know, we would be very surprised. So how to cope with that? Yeah, there's no any magical material coming into the market that is going to be introduced. There's no more time, definitely. The codes are not getting any, not bringing any simplification. So we believe that the only way how to have the technology, how to make our lives easier, it's through technology in our tools. And every structural engineer nowadays already use global analysis models, the FEAs. Some of them, they also use BIM tools, Tekla Structures, Revit, the FEA tools such as StartPro, ETABS, Sub 2000. They're great tools. Use them, of course, but these will not help you with the complexity of structural details. And this is exactly where IDEA Statica comes in. So the main ones that consume the most time on every project are steel connections, both complex and simple. All of them can be done effectively with IDEA Statica, much more effectively than with the solutions that are out there currently with the Excel spreadsheets, with the simplistic library tools like RAM Connections, Limcon, or others. And yes, even the simple ones. The concrete details, another big group of complex structural details, everything with the discontinuity, openings, anchorings, topic for today, the walls with windows, pile caps, pier caps, coupling beams, all of this is where Idea Statica brings value. Another topic, BIM workflows. Yes, BIM is a nice buzzword and it's a great vision, but in its complexity, it's not just there yet. But for structural engineers, if they want to automate the import exports, the data exchange, this is already there. This is already possible with Idea Statica. And the last group of big issue now on a nowadays market, if you are required to design or optimize your projects for material usage, you need to do slender buildings, slender constructions, stability issues, buckling issues. This is what comes what comes with it. So this is another topic where Idea Statica helps. So the technology is there. The tools are actually getting improved. So now we just need to use them and make sure that we leverage the first and last bits of it. And this is actually where GSD Idea comes into place. Our company that we represent, we are the one and only first level reseller of Idea Statica for the territory of GSD. And we're, of course, focusing on the sales and after sales support, but that's not it. We know that implementing every new technology requires actually digging a little bit more deeper. So there's various onboarding sessions that we do for our customers to make sure that really they know the basics of what Idea Statica can do for them. Again, not just the complex connections from the previous slides. You remember what it is. What's the rest? If you want to get proficient in very specific topics, you want to improve your modeling skills, you want to understand the details of every analysis, again, the stability, buckling issues, very rather complex topics. We have hands-on training session, 2-3 hours, really practical, can be grouped to cover more topics. Definitely a way how to adopt Idea Statica. And the implementation services related to, again, various use cases. So if you really want to get rid of your Excel spreadsheets or from the simplistic tools, just let us know and we help you set up the parametric templates for the everyday typical connections that you're designing. If you want to step it up a little bit in terms of the parametric design, Rhino, Grasshopper add-ons tools can really help with a visual programming language, and again take the parametric design to the next level. And in case you struggle with repetitive tasks around Idea Statica or around your designs, again, let us know. We provide implementation and development services. You would definitely not be the first customer of Idea Statica. At this point, we have somewhere around 500 customers. Here you can see the list, just a few of them. Another metric that we found out quite recently through our research is that actually 2 out of every 3 projects, iconic, here in the GCC. So if you imagine all those interesting projects that are happening in UAE, Saudi, 2 out of 3 are already being designed with Idea Statica, and we can even be more optimistic, and say that they would probably not be even able to be designed without Idea Statica easily. So that's it for the introduction. Before we deep dive into the anchoring topic, we would like to know your input, and that input is actually, we would like to know how often do you design anchors and the design fail due to concrete capacity. So Dominic, can you launch the poll, please? Okay, poll is in progress. So let's have 30 minutes of the votes, 30 seconds of the votes. So often, meaning once every week or 2, sometimes meaning once every month, every quarter. Hardly ever. Is really like occasionally once per 6 months, once per year. It never is really. You just don't face this issue, or you don't do such projects. Okay, 30 minutes out, so we can close the poll and share the results. So we see that really anchor issue, it is an issue. It's a huge issue, in fact, and so it only confirms what we hear and see around the world. Yeah, there's 42% people dealing with this on a weekly or bi-weekly basis, and 45% of the people they face it on a monthly basis, give or take. Yeah, so it's overall it's around 87%. So it's a majority. There's almost nobody, only a few participants here, never facing this issue. So it's good that we're right on point, and we can move on. So Rose, please do give us introduction into the anchors and the issue we're facing.
Yes, sure. Let me just share my screen. Jan, can you please confirm if my screen is visible? Right. Thank you so much. Thank you. So let's start by asking the fundamental question, just like how Jan asked, why? Why do we need to address the anchoring issue in the first place? Why should we even consider solving a challenge that many structural engineers frequently encounter when designing our foundations? When designing anchors in a concrete structure, as we all know, we face a range of potential failures, which is also outlined by the Eurocode. Now, some of these failures are related to the anchors themselves, while others concern the concrete, such as the concrete pullout or the concrete breakout failures. And among these failure modes, as we all know, concrete breakout is often the most critical one. It can lead to the failure of the entire design, making it a crucial factor to consider in anchor design. And the question now is, how can we prevent this? One option is that we can make the concrete block a bit bigger in size, that is larger, deeper, longer. But the solution is often not economical, or there may be space constraints to consider for this. The second solution, as we all know, is reinforcing the concrete. Now, by adding reinforcement, the concrete breakout can be prevented, and we no longer need to account for it. However, Eurocode also specifies that we need to design a supplementary reinforcement. Now, what are these supplementary reinforcements? Reinforcements that are placed inside the concrete to carry the load once concrete breakout occurs. Now, this introduces another challenge, calculating the forces from the anchors and ensuring these are properly accounted for when designing the supplementary reinforcement. And another important aspect is that the concrete block may already have a reinforcement in place. Now, in this case, we don't necessarily need to add supplementary reinforcement specifically for the anchors, as we can utilize the existing reinforcement. Now, the Eurocode allows for this, but it does not prevent or provide clear guidelines on how to do so or how to calculate the effectiveness of the existing reinforcement. And this gap is one of the key reasons why Idea Statica is introducing this feature. And another trouble, another challenge I would call arises when anchors are placed in close proximity to one another, creating a shared concrete cone. Now, this scenario is not thoroughly covered by the design codes, so we must address it separately. And this brings us to why Idea Statica is such a valuable tool. The solution lies in the 3D detail application, which allows us to handle the failure of anchors due to reinforcement or under-reinforced concrete blocks. It also accounts for situations where multiple anchors are grouped together and addresses the challenge of designing anchors in concrete block that already have reinforcements installed in it. Now, to summarize the question that Jan has just asked, the why is simple. Ideastatica provides a quick and effective tool to assess the capacity of reinforced concrete in anchored designs. It also helps addressing challenges not fully covered by the code, offering the ability to deliver code-compliant but safe outputs. That concludes my introduction. I will now pass the presenter to Dominic, who will now explain to all of us how to use the application to achieve the features I've just discussed. Dominic, are you there?
I am Rose. Can you see my screen?
Yes, I do.
All right. Let's get to it. Thank you so much for the introduction and answering the question why. I will be showing how, because I want to talk about the complete workflow of the anchoring solution Ideastatica provides. In some cases, it is tough to solve the anchoring tasks even with Ideastatica connections. And those cases are, as you have said, close to the edge anchoring of to a concrete block, or multiple group of anchoring groups close to each other. And as we know, the code check fails due to lack of reinforcement or the lack of knowledge how to consider it. That's why 3D model type was developed for the application of called detail. And when dealing with anchoring, the reinforcement is taken into account according to the design code. Let's have a look at it, how it goes. So you start in Ideastatica connection. Most of you are familiar with this. You design your anchoring close to the edge of the concrete block, but you experience a fail of the anchors due to the concrete cone breakout, for example. Well, in this point, this is new. You click on a button. We will see that by Venkatesh. Export this information into Ideastatica detail, where you get the concrete block, base plate, anchors, and the forces acting on the base plate and the anchors. Then you just introduce the reinforcement, add additional load cases, and run the analysis, and to get the complete results of your design. Both applications together cover all of the failure mechanisms stated in the code, Eurocode 1992-4. In connections, you can investigate the pull-up, the steel failure in steel, and in detail all of the rest, considering the reinforcement. Now, I have prepared a little Q&A to explain the differences between connection and detail. Let's start with the first question. How is the design of anchors and concrete carried out? Well, in connection, the concrete house is carried out on a reinforced concrete, and all of the checks are carried out as the empirical formulas stated in the code. On the other hand, in detail application, where the 3D model type is implemented, the concrete block is modeled with 3D solid elements and is reinforced. In fact, it must be reinforced. This application is developed only for the reinforced concrete only. It utilizes the method called 3D CSFM, but more on that a little later. Second question, how is the concrete block modeled? Well, in connection, the block in the 3D view is only a visual representation. The block is modeled with a subsoil model with nonlinear springs active only in compression, which provides the stiffness of the concrete block, allowing only for the transfer of compression. The contact stress is calculated using formulas and averaged over the effective area as the code describes. To the contrary, in detail, as I have said, the concrete is modeled with 3D solid elements. Here you can see it meshed. And the triaxial stresses are considered in the characteristics of the material. As a result, you get the principal stresses compared to the concrete strength in compression. Third question, how is the load exported? Let's take it from the top. In connection, you load the model, the shell elements with the internal forces you receive in your global analysis software. You run the analysis and receive results, equivalent stresses on welds, on plates, and forces in anchors, as you can see. Then once you export it into detail application, it is a bit different representation of the same results. You get a group of forces, which is the equivalent stress in the welds acting onto the base plate, and then group of forces acting in the anchor. They are exported as a two. First, there's a tension force in the anchor, and there's another one acting in the opposite direction, ultimately maintaining the equilibrium. With this, this way, we are able to achieve the consistency in the design. You can see that the bolt force over here in the anchor is matching perfectly. Last question: is concrete considered cracked or uncracked? In connection, you as a user can decide if you consider the concrete as cracked. You can modify this in the project settings, in the analysis, and check the checkbox whether or not you want it cracked or not. And in detail, by the nature of it, it uses the 3D CSFM method where the concrete in tension is neglected. So it depends on the load level in the ULS state whether or not the concrete will crack. Well, this was my last question from the Q&A. And now let's move on to the 3D CSFM. I have mentioned this a couple of times, so I want to clarify what that is. The method of 3D CSFM is implemented in the application Ideastatica Detail in the 3D model type. This method is a nonlinear finite element calculation method capable of considering the reinforcement. To explain some of the basics, I would like to use the CSFM, which is the younger sister of the 3D CSFM method, compatible stress field method. So we'll stay in the two-dimensional space for a minute. The CSFM method is an evolution of a probably known method to use, strut and tie, but it is not strut and tie. It is much more sophisticated than that. The CSFM principle can be explained using the basic 2D plane stress element in a reinforced concrete structure. The picture on the left illustrates this element under horizontal normal stress, vertical normal stress, and shear stress over here. These stresses are often derived using finite element analysis, are used to calculate the principal stresses and their orientation defined by the angle theta, shown in the picture over here. The principal tensile stress is sigma 1 and compressive stress sigma 2. And using CSFM, the stress on the same element in the picture on the right, concrete compresses with the sigma C2, but concrete in tension is neglected. Therefore, sigma C1, the tensile stresses is 0. So how do we transfer all of the tension in the model? We need to use the reinforcement, which in this picture is represented by the blue lines. And that is why the concrete must be reinforced in detail application. So if I were to sum it up a little bit, the method is based on a finite element method. In the 2D space, the concrete is modeled as a 2D wall element. Reinforcement is modeled as a 1D element. They are connected together with a bond element, so they are modeled independently. And loads are applied in increments. There is a non-linearity stress and strain diagrams used for all the materials, and the results are continuous stress fields in concrete and tensile or compression stresses in reinforcement. As you can see in this picture, there's a nice demonstration of the compression fields in this pier cap The black lines represent the direction of the principal stresses, and blue represents the tension, and you can see that you can only find it in the reinforcement. And with the 2D CSFM, you can cover both ULS and SLS. Now, finally coming to the 3D CSFM, which is just augmented into the third dimension. And this is done by considering the three-axial stresses. The triaxiality is considered with the Moore-Coulomb theory of plasticity. This method is suitable for brittle materials, therefore suitable for concrete as well. And we have further modified the assumptions of this theory in two ways, quite conservatively. Firstly, since the concrete in tension is neglected, a tension cutoff is performed. So this area is neglected. And secondly, the angle of internal friction is conservatively appointed as 0. And the practical impact of the triaxiality, in other words, confinement effect, is that when a concrete element is exposed to compressive stresses in lateral direction, the load-bearing capacity of concrete increases, as you can see in this picture. So here is the Moore-Coulomb model, which can be found in the 3D CSFM method. We see the tension cutoff. There's nothing acting in the tension, only in compression. And the blue line demonstrates the linear Moore-Coulomb plasticity envelope, the internal angle of internal friction, constant, set to 0 degrees. And the practical consequence of introducing a 0 angle of internal friction is that the maximum possible difference between sigma C3 and sigma C1 remains constant for any value of sigma C3 and the value of sigma equivalent, the equivalent principal stress. Therefore, can be directly compared with the uniaxial compressive capacity of concrete defined by the standards, as you're aware of. If you would like to know more about this theory, go ahead, visit Ideastatica's website, Ideastatica Detail, Structural Design of Concrete with 3D Discontinuities, where you can find additional information. As it is standard for Ideastatics application, the method is verified and validated. We have performed a number of verification tests with laboratory experience as well as with other finite element tools, and we're achieving good results, so you can be safe to use the design. Well, that is the first end of my presentation, and I would like to now ask Venkatesh to show us how it is really done in the application. Venkatesh?
Yes, Dominic, and thank you for the theoretical background behind the detail, and I will share my screen. Dominic, can you see my screen? Great. Fine. So let's continue with the practical demonstration of the 3D detail application. Here in the steel connection module, you can see a simple base plate connection, which was connected to the plain concrete through anchors and base plate. And to ensure it is critical, we provided anchors to the edge of the concrete. And after analysis, I can see the anchors are failing. So I will check why the anchors are failing. We'll go to the check tab, anchors, and I will expand the results. And here I can see the anchor is fine in tension. So the capacity of anchors is greater than the load acting. So it's fine in tension. And as well in the shear resistance, the capacity is greater than the load acting. So it is fine in shear as well. So the problem is with the concrete where the capacity of the concrete block is less than the force acting. So basically here the anchors are failing because of the anchor failure, not because of the steel failure. So we don't have to change the grade of anchors or increase the die of anchors in order to make it work. So as one of the options, we can provide additional reinforcement in the plain concrete block for us to make the connection safe. So in order to do that, we do have an option in the steel connection module. On the top middle, you can see a button called RC check, which is nothing but reinforced concrete check. Just clicking on the button will export all the information required from the steel connection module to a separate module, which is known as 3D detail module. Well, before clicking the button, I want to give some pointers. Make sure that your steel connection module is analyzed, because if you're not analyzing your steel connection module connection, the RC check button will be disabled. Only once you analyze your connection, the RC check button will be activated for you to export your data. And also, as of now, the reinforcement check can only performed in a Eurocode, EN Eurocode. And as per ACI, it's under development and will be released shortly. Maybe Dominic can give some information on it a bit later in the webinar. So let's proceed with the export option. I will just click on the RC check button. It will ask me to save the file. I will save some name, which is RC check, and save. And just give it a moment. It will be opened automatically. You don't have to click on it for it to open. And yes, it's taking a bit of time. It won't take this long actually. Just give me a minute. Well, finally. Yes, so this is the tab which was exported from the steel connection module. So this is called as 3D detail module, in which we can add the reinforcement to your plain concrete, to the reinforced concrete checks. So let me just introduce the user interface. As you can see, it is similar to the steel connection module, where you have the tabs, 5 tabs in the project tab. You can fill in the information about your project, author, description, and everything as you require. And in the design tab, where we perform all the operations for the basic modeling. And you can also see a few of the elements which were exported from the steel connection module, like concrete, anchors, and the base plate. And in the check tab, it's like the post-processing. You can see the analysis output after you've done the analysis. And report tab, where you export the report. And materials tab. Here I can already see a few of the materials which were already exported from the steel connection module. So the like grade of concrete, grade of anchors, grade of steel base plate, everything. If it was specified correctly in your steel connection module, it will be automatically exported into the 3D detail module. You don't have to worry about it. So let's jump back to the design tab. Yes, so in the design tab, you can see these items under detail 1. So these are basically the items which are exported from the steel connection module, and each item has its own parameters on the right side, so you can change them as required. So let's go through each of these items just to make sure what is exactly getting exported from the steel connection module into the 3D detail module. Now, if I click on the first option, detail 1, this tab, these parameters are the default parameters which you can set as default before creating any new reinforcement or adding any new item. It's like a default settings. So for this demonstration, I will change the concrete cover to 50 by default. So if I add any reinforcement, the reinforcement will be created at a, cover with a concrete cover of 50 mm. And you can also change the overhang and the length of stirrup branch and so on. You can also change the type of anchorage. For this demo, I would like to go with the bend bars, and also direction of concreting, sulfate direction. This is by default. If you want it, you can change it for your default settings. And the first item which was exported from the steel connection module is the CB1, which is nothing but a plain concrete block. So the information with respect to the width, depth, and the height of the block are exactly exported from the steel connection module, along with the grade of concrete, which is C2530. And next are the supports. A support will be automatically created if you assume the block to be a isolated block whose sole purpose was to transfer the loads from the column. Then this should be resting on the soil, so this does make sense. However, if you need any additional supports, like you can just add them like new support, and you can assign them to any of the edges, sides, or uh, other locations. Here I've considered the whole support for the whole surface. We can also partially support it. Instead of supporting the entire surface, you can also provide a partial restraint for it. So let's see how it can be done. So I will see the parameters in the support where I have these options. I'll start from the bottom, where the support is assigned to the concrete block 1, and this surface is nothing but the surface index. Like the support should be assigned to which index. So you can see some numbers here which are 1, 2, 3, 4, 5, 6. So these are the index. So in order to assign these supports, you have to select the appropriate index which is required for you. And also here I choose the whole surface to be supported. That's why the whole support was assigned to the whole surface. So you can also change it to the polyline, where the restraint can be partially supported, and you can create multiple partial supports as required. But for this demo, I will go with the whole surface. And on top of it, I can see the surface support in all XYZ directions. These are nothing but stiffness values. Generally, these are not constants. These are variables depending on the type of soil which is under your concrete block. So you can get those values either by calculating by using allowable bearing capacity of soil and allowable settlement of the soil. So as you can see, these options are editable, so you can change it as per the type of soil presented in your case. And make sure this compression only spring support is switched on in the vertical direction. The support should be acting in a compression. And next are the transfer devices, where the base plate, grade, and the width and depth, and the thickness of the base plate are again exported from the steel connection module. And positions were assigned as per the model which was there in the steel connection module again. And at the bottom, I can see the shear force transfer mechanism. In 3D detail, you can choose options on how to transfer your shear force. One of the option was to use friction. If you're choosing friction, make sure you change your friction coefficient as per the standards or as per the code. And you can also choose shear lux to transfer the shear force. where if you choose shear lug, you have to define the cross section of the shear lug and all the informations related to it. And if you choose anchors, the forces will be transferred through the anchors itself. So you have the options to choose for the shear force transfer mechanism. And all the anchors which were there in the steel connection module will be exported as an individual items. So corresponding to each anchor, the diameter and the material are exported from the steel connection module. In the 3D detail module, we do have two types of anchors which can be analyzed, which are adhesive anchors and the cast in place anchors. If you're choosing the cast in place anchors, the capacity of the anchor will be automatically calculated based on the code. And if you're choosing adhesive anchors, well, the diameter and the material, you will get it from the steel connection module. However, the bond strength, this is the default value. This is not constant and it's variable. So based on the type of adhesive you're using, like the type of adhesive anchors you're using, you have to refer to the manufacturer's catalog, get that bond strength value and update the value here. Yeah, next we have interconnection with a base plate. We do have two options, which is active for axial force transfer, active for shear force transfer. And if you are exporting your this RC detail from the steel connection module, then make sure to switch off the active for axial force transfer. This is because the forces were directly applied to the anchors themselves. So no need, I mean, this should be switched off if the detail was exported from steel connection module. However, if you are starting it from scratch by not exporting the module, then you have to switch it on. This was already explained by Dominic earlier in the session. And active for shear force to be switched on, and you can control, since every anchor is exported as an individual item, you can choose which anchors will transfer the shear and which anchors will not. So if some anchors are very close to edge, you can avoid the anchors to transfer any shear force by just switching it off. And the rest of the items are modeled as per the arrangement which was there in the steel connection module. So the next item was the load cases. So if I see the load cases, as I told you, the axial force to be switched off because the forces were directly applied as a point load to the anchors here. So you can see the magnitude on anchors. So for ease of understanding, I will just cross-refer this with the steel connection module. So I will go back to my steel connection module. I will go back to the bolt forces. So here you can see it's 75.4 in tension and 7.2, and the other two anchors are 0, 0, and the same is applied here, 74.4 and 7.2, and there is no forces on the other two anchors here. And all the remaining forces are transferred as a group of forces here, as you can see, like a group of forces. And next item is combinations. Yeah, before going back to the combinations, let's see how to add the any additional load cases. Current case, I'm considering it an isolated block without any external effects, so I don't want to add any more load effects. However, if you want to add, you can add the load cases. You can go to the option here, add a load case on top, or just right click on it and go to new load case and add it. In this module, I want to add the self-weight of the pedestal. Since we are taking stiffness supports from the soil, I want to consider the effects of dead load of the pedestal as well. So I will add a new load case, which is LE2, and In the right side parameter tab, I can choose plus, which is add new entity. Here you can choose like the type of load you can add to your project. For this case, we are using the self weight of the concrete block. So I will be selecting the self weight, and there is only single concrete block. So it's by default applied to concrete block. If you have multiple one, you can choose on which block the self weight to be applied. So you can see the difference. So LE1 is the forces which are exported from the steel connection module. LE2 is the self weight of the concrete block. And next item is the ULS combinations, where you can define your combinations. If I select LE1, I can see the parameters, combination and combination rule. On the combination rule to the right, you can see an edit button where you can customize your load combinations. Like LE2, in this case, I want to consider both LE1 and LE2 load cases. So I will change the combinations accordingly. So LE1 plus LE2. And before proceeding, make sure, as a note, like only the ULS combinations are analyzed in the 3D detail and not the individual load cases. So make sure you define your combinations properly. And let's start with the modeling of reinforcement. Oh, before we proceed, I can see a warning here, which is a non-conformity. No reinforcement is defined in the model. So what does this mean? So the 3D detail module is only for the RC check, so reinforced concrete check, not for the plain concrete check. So if you don't add any reinforcement, error will pop up and you can't even perform your analysis. So let's proceed with the reinforcement modeling. So on top, you can see the rebar assembly, add new rebar assembly. Just click on it, and you can add any type of bars using this option. Just click on this option. So as soon as I add some default rebar, the warning was disappeared. So it is meant, this 3D detail is meant for reinforced concrete check. So I will start modeling my reinforcement. This is the reinforcement item. On right side, I can see the parameters. So I will go with the rebar diameter be 10 mm. Material grade, I will leave it as it is. You can update as per your project requirements. And here, by default, it is choosing standard bend rods, because at the start of the project in detail 1, I defined the default bars as bend bars, and I gave concrete cover to be 50. So this is the purpose of the default settings. If you add a new item, then the default settings will be applied to that item. However, you can change whenever you want. To make things easier for you, you can save the defaults if you have more reinforcements like that. So, okay, fine. So shape definition. So before I start with this process, I would like to highlight the numbers which were displayed here, which were nothing but the indexes of surfaces and edges. So the modeling of the reinforcement is solely dependent on these indexes. So since you have done your connections, if you are aware of steel connection design, then it's the same thing here as well. So you just define your reinforcement based on indexes. So how, okay, here I can change from on surface edge to on surface edge on more edges. So I can change the surface cover. I can put to 60, which is nothing but the spacing between the rebar and the concrete edge here. And number of layers I can define, I will choose 7. So you can take a view to see how it's happening. It's going outside. So I will reduce the distance of layers from 200 to 150. And of course, there is only one block. There is no 2 blocks. So by default is applied to the default block. And surfaces, as I told you, this is the surface index, where you have to choose on which surface you want the rebars, which is 1, and edges you can select like this. So first surface here, the rebar was chosen parallel to the surface along the 4 edges, 1, 2, 3, 4. That's what this means. So it's pretty simple to model the rebar in a 3D detail module. So I will continue with the rest of the modeling of the reinforcement. I will just make a copy of it, and I will just change the surface index from 1 to 2, and I got the reinforcement in other direction. I will model the vertical reinforcement, where I will copy it again, and I will change the surface cover to 100, and I will go with 3 bars, and distance of layers 200, and surface I'll put 5 since I want it as a vertical bars, edges 1, 2, 3, 4. And one more thing, it is getting clumsy because I'm modeling a lot of reinforcements. So if you face the same issue, you can always choose to switch off the option of rebars on top of it. So you can see the reinforcement of each item you selected, so that it's pretty easy to model it for you. Fine, so I model these 3 items. So, and one more thing was the shape position. This was edge cover type was chosen from the default settings which we assigned on at the start of the project. You can also change it to user value. You can define the values here, like maybe 100 might be the cover, or 200, whatever you want. So as of now, I'm going with the from settings. So I have to also model the vertical rods, vertical bars. So for it, I will choose 8 diabars, and I will change from more edges to on surface edge. I'll change the surface cover to 150, number of layers 4, and distance of layers 250. So distance of layers is nothing but the distance between these rebars here, and number of bars in layer to be 4 and 250, and concrete block surface edge to be 1, edge to be 2. Fine. So you can adjust your position in on which side you want, and I will change edge cover type from settings to the user value, where I will assign some 150. So yeah, that's all. Our reinforcement modeling is done. So it's pretty simple. All you need to remember is the indexes, that's all. So if I switch off the option on top of it, I can see the whole reinforcement, which was modeled to analyze the connection. So yeah, that's all. We can run analyze with the connection. However, to save the time of the analysis, I have already analyzed the connection, same connection here. Oh, and one more pointer before I proceed with the next steps. Uh, the reinforcement is an iterative process. So we have to add the reinforcement, subtract the reinforcement, so which involves a lot of iterative analysis, iterative calculations. So to make things easier for you, you can always go to mesh settings and change the mesh settings to 2 or 3 for your iterative process, and achieve your desired arrangement of the reinforcement. Once you achieved your desired arrangement, you can always change it back to 1 and complete your analysis. Yes, so that's all with respect to the modeling part. Let's shift to the after analysis part. So after calculation, you can see on the left side all the analysis results, brief results, which represents the utilization, which says the concrete and the reinforcement and the anchorage are safe and well within the 100% limiting limiting ratio. And to study it, we can go to the check tab. In check tab, we can see the summary. So the 3D visualization which we can see now is the stress transferred inside the concrete block. So how it is transferring, you can study the behavior of it, and you can also go to the scale. You can scale it up to have exaggerated view and so on. And you can also go to the strength tab here. You can go to the concrete, and you can also go to the principal stresses. And here I can see the principal stresses heat maps, and along with the scale, stress scale, you can compare each stress zone with the respective zone. And also we can create a section if you're interested in studying about the concrete block, what's happening inside, then you can create a section as well. And if you like it, you can add it to your report like this. So I can see what's happening inside, and I can always compare with the stress scale here to see what's happening, and you can always add it to the report. And similar to this, you can do the reinforcement utilization checks. You can compare with the scale, and you can also see the anchorage and all that information. So basically this check tab in detail was to provide those 3D visualizations like stress, strains, and deformations. The deformations for you to study and understand how the concrete and reinforcement behaves. It helps in making informed decisions about the design or any necessary adjustments. In the auxiliary tab, you can also see the deformation. You can see the displacement values as well. And finally, you can go to the report where in 3D detail, it's similar to the connection module. You can customize your report by adding, subtracting, what are the features you want, and generate the report. Once you generate the report, it will be this nice presentation, which includes all the information which was added into the 3D detail module, as well as the information which is exported from the steel connection module, along with the 3D visualization of stress flows, principal stresses, strains, deformations, and so on. Yes, so that's it for practical demonstration. Dominic, Dominic, are you there?
I am Venkatesh. Thank you very much for the demonstration. All right, I think my screen is on, so I'll quickly wrap it up. Let's have a look on what to keep an eye on during modeling. In connections, there are a couple of ways how to define the anchors. You have number of parameters here. You can select the type of an anchor and together with the material anchor type, and how the shear force is transferred on this operation. So whether or not it is the friction anchor or shear lug. There are two types of anchors according to the installation. The first is cast-in, otherwise known as pre-installed anchors. They can be further divided into three types: straight, then hooked ends, and then anchors with washer plates. The second type of anchors according to the installation are the post-installed anchors. They can be adhesive or mechanical. Unfortunately, in Ideastatica connection, neither or detail, the mechanical anchors are not supported. For the adhesive anchors, the technical specifications of the anchor manufacturer must be used. When the straight or hooked anchor are set in connection, they are exported into detail as the following. they are exported as an adhesive anchor. And over here, you can define the bond strength. This would be a design value of the bond strength according to the manufacturer of that anchor. The hooked anchor type is exported as pre-installed reinforcement rod with a standard bend according to the Eurocode. In detail, there are more anchorage types. They can be further modified after the export. Venkatesh has already shown that. Notice there are straight, hooked, looped, transverse bar, perfect bond, or continuous bar out of the concrete. Notice, however, that the code only recognizes 3 types of beta factor to consider in the anchorage calculation, and that's 0, 0.3, or 1. And yeah, the bond strength for the adhesive anchors, as I said, it needs to be taken from specifications from the anchor manufacturer. There's a nice bond strength for anchors in detail 3D knowledge base article on our website, so go ahead, you can study that. And let's have a look how the transfer of load is carried out. The load can be defined either to the anchor directly, and in this case, the load is transferred to the concrete directly, the tension, the compression, and the shear as well. Or in the other way, the load is defined on the base plates, and you can select which anchors are used to transfer the loads. Why is that important? Because sometimes you just want to select 1 or 2 anchors according to the code. You can, as Venkatesh has already displayed, interconnect the anchors with the base plate. And this is very important for the shear transfer as well. The shear can be transferred via friction, shear lock, or anchors. Firstly, the friction between the base plate and the surface. The anchors, according to the Eurocode, or the shear lock, as I have said, they cannot be combined together because that is not possible with the design code. Let's have a look at some wrap up. I select these 2 anchors to the edge to transfer the shear, calculate it, do the whole process which Venkatesh has shown us, and I can see the deformed shape, the auxiliary result, how the behavior of the concrete block. I can see the utilization. Notice that only the anchors that I have selected are acting and are being utilized, and I can see the heat map of equivalent principal stress on the concrete block as well. Now, let's wrap it up. What is the complete workflow summary? After you perform the connection design, you import an anchoring to the detail application, check the supports, then design the reinforcement according to the standards for adhesive anchors, define the bond strength according to the manufacturer specifications, select the anchors you use for the shear transfer by clicking the shear checkboxes, run the analysis, check the results, and then turn in the report. During the webinar, I've got some questions about some limitation and what's next for the detail application. Well, in the version 24.0, which will be released during April, so next month, we will have the ACI implemented, as well as casting plates, headed studs, base plates with a gap, and the possibility to have groups of anchors exported, to have more concrete blocks, create openings, and many more additional features. Okay, that's it for me. Jan, I'm passing the word to you.
Thank you, Dominic. So let's conclude this webinar. I will share my screen as well. So today we've been through the whole topic of anchor design, why it is such an issue, what Ideastatica has to cover engineers, structural engineers back. And as we saw, it was a big topic at the beginning. We would very much like to invite you to either test the solution. If you're ready to, if you're convinced and you would like to procure the license, we have a Ramadan promotion ready to be launched today. So for every participant here on the webinar, no matter whether you are existing customer and you already possess Idea Statica license, typically it would be Idea Statica Steel, you can upgrade to Idea Statica Complete, which is the complete portfolio of Idea Statica applications that will allow you to calculate the anchoring issues, the anchoring designs and code checks as well. So that's one of the options. If you are a customer, yeah, we have, of course, conditions for you as well. Complimentary onboarding session for all those who will want to get on board. But be aware that this deal is valid only until the end of Ramadan. After that, Idea Statica already announced some changes within the price list that will go together with the release of a new version. So now it's the time to move forward. So what's next? Whatever you would like to explore more in terms of Idea Statica, in terms of anchoring, you would like to test, you would like to have a trial of Idea Statica, go to Idea Statica webpage, go to GSD webpage, you're free to do it. If you're an existing customer, reach out to us. If you want to upgrade the seat or add additional one. If you already have what you need to have in terms of license, we're here to support you with your adoption journey as well. info@gsdidea.ae, reach out, go to GSD Idea AE webpage. There is a chat bot, we're online, drop us a message or call directly. And that's it. That's it. Ladies and gentlemen, we did enjoy our session a lot. I hope you did enjoy it as well. So that's it to conclude our webinar, and we hope to see you at the next one. Have a great day. Bye-bye.
Bye, everybody.
Everyone, thank you.